please just wait for a minute.
Okay, sure.
Yeah. Yes, Vijay. Please, you can start the program.
Yeah. Thank you, Renuka ma'am. Yeah, once again, I extend a warm welcome to Professor Dr. Saida Tabassum Sultana Madam, the resource person for today's session, and all the participants who are here for the technical session in the 10-day FDP program on advanced research methods. I would like to introduce Madam or Dr. Said Tabassum Sultana ma'am, the resource person for today. Madam has been working as a principal and a professor at the Mathrusri Institute of PG Studies from Hyderabad with a teaching experience of 2 decades at PG level. Ma'am holds an MBA in Finance and Marketing from Osmania University. She has completed her MPhil in Management and subsequently awarded PhD in Management by the Osmania University for her work on investors' behavior in the area of behavioral finance. She's also cleared UGC NET and AP SET for lecturership, and her additional qualifications like the postgraduate diploma in computer applications, MA Economics from Osmania University, and MSc Psychology from Madras University illustrate her intellectual fervor and her academic vibrancy. Her areas of research include behavioral finance, investment management, and marketing. Ma'am has completed many faculty development programs from IIM Kozhikode and also attended FDPs from IIT Madras and Kharagpur. Ma'am has an impressive research profile. She's on the editorial board and reviewer of reputed international and national journals. She has published 32 research papers in national and international journals and presented 28 papers in various national and international conferences. She has 1 patent to her credit and also is honored with 2 awards for her contribution towards research. She has an H index of 6 to her credit. Ma'am, it's an honor to have you here with us today, and we look forward to listen to your lecture on today's technical session. So once again, a warm welcome, Dr. Saida Tabassum Sultana ma'am.
Thank you so much, ma'am. Thank you for the elaborate introduction. Before starting the session, I just would like to thank Dr. Renuka Sagar ma'am for inviting me for this session. I hope I will make some difference to all the participants. When I attended the inaugural session, I got to know that 800 plus people have registered for this session. And right now I can see 200 people in this Zoom session. I think the rest others are on YouTube listening to us. Let us start ahead. Starting the session, let me share my slides. Yes, are you able to see my slides,
yes,
all of
yes,
you?
Dr. Tabassum, we can see.
Yes, ma'am. Yeah.
Yes, a very good morning to one and all. Before starting the session, I just want to say a few words. First and the foremost, I'm not a statistician. I'm not going to speak the language of statistician. That's the first thing I want to make it very clear. I'm just here to throw some light on the topic given to me. And please understand, this 1.5 hour session which is given to me is not sufficient to give the entire knowledge which is required for understanding this. But I'll try my level best to give you certain basic knowledge and also provide you with certain material which will be helpful to understand. First and the foremost, what you're supposed to keep it in mind, especially while learning research methodology, you can learn certain basic concepts from other people. The rest other learning goes by self-learning, especially by exploring things. Okay, whenever you attend these sessions, they give you certain basic knowledge. which will motivate you or help you to understand further when you start exploring things. That is what I want to make it very clear. I hope I will, by the end of this 1.5 hour session, I'll add some value to each and everyone here, if not all, at least few people who are listening or concentrating on this particular session. Yes, coming to the topic given to me, this is the topic that is exploring the assumptions. Just a second. Exploring assumptions of parametric data, that is parametric test, dependent and independent sample t-test, ANOVA, repeated measures of ANOVA. This is the topic given to me. The flow of the session is going to be as follows. That is, first I'll touch upon certain basic terminology which we generally use it. Then I'll just run through what is meant by normal curve. Many people I observed that they use this word normal distribution and normal curve while doing some research work. But basic understanding, I feel personally that it is missing. Okay, for that reason, I just want to focus a little bit on normal curve. Then I'll just quick run through. I'm not going to elaborate on this hypothesis testing procedure. The assumption is most of you know it because you are doing your research, because of which you might be aware of it. The second thing, and the fourth topic is types of parametric test. Under that, I'll be focusing upon t-test and ANOVA when each of these tests are applied. And then we will be exploring the assumptions of the parametric test, right? I hope I'm audible to all of you and my slides are visible to everyone, right? Going ahead. Before going ahead, I just feel that at least some indication that people are listening to me, if I get, that will make me motivated to go ahead, because as it is an online session,
yes, ma'am,
many advantages, and also one of the major disadvantage is we cannot see the audience. That is the major disadvantage, right? Yes, going ahead. Most of you people are aware.
Hi, ma'am. Sorry for interrupting. If you don't mind, can you put the slides on slideshow mode?
Yeah, sure. I'll do that. Is it fine now? Yeah, going ahead, coming to the basic terminology, the first and the foremost word is population. It refers to the collection of individuals under a study. It is generally also we use the other term for it as universe. The individuals are often called the members or the units of the population. They can be a physical objects or measurement expressed numerically otherwise certain times, right? The next the word which you are supposed to familiarize is the sample. In general, whenever we conduct a research, we are not going to study the entire population.
Sorry to bother you, but I think you are on a different slide from what you are explaining us.
Is it so? Now, ma'am, is it moving?
I think it's not moving. It is there. It's stuck. Basic terminology, Dr. Tabassum.
Now?
I don't know. I'm not able to see that the slide is changed. I think now.
Now ma'am is on the no. The previous slide she was actually on the right
no,
slide.
Actually, what's happening is
now it's moving. Dr. Tabassum, it's moving. It's moving now.
But it is not going into PPT mode.
No, it is not in the slide. That is slide show mode.
Ma'am,
you can go for a full screen.
You need to share the whole screen. I think you have shared a window. While sharing, there comes options share screen, window, or you need to share the screen.
Actually, I'm more familiar with Google Meet. For that reason, all these problems. Let me try once
So you,
again.
you can stop sharing, ma'am, and you can start afresh and sharing the whole screen. Then the slideshow mode will come.
Okay, right. Thank you. Now, is it changing?
Yes, ma'am.
Yes, it's up.
Yes. Yes, going ahead, and sorry for that interruption. Due to technicalities, we have to address such things. Yes, going ahead. As I said, in general, whenever we are doing the research, we study the characteristics of the, actually the focus is to study the characteristics of the population. For that reason, what we do is, we select a part of that population, which is referred as a sample. And based on these characteristics, we try to conclude the characteristics of the population. That is what we do. The fundamental object of sampling is to get as much information as possible of the whole universe by examining only the part of it. As I said, if you're studying the entire population, it is referred as a survey study. But while doing a research, it is not possible to do a survey study. For that reason, we analyze the characteristics of the sample, and based on that, we try to conclude. Right. Now, the next one is the parameters. In general, because our study is focused on parametric tests, for that reason, you're supposed to know about this, that statistical measures such as mean, which is represented with mu, and variance, that is sigma, etc. of the population are called as parameters, right? I'm sorry, it's not moving.
Ma'am, if you are not comfortable, we shall do that for you, ma'am. You can share it with us.
Okay, just a second. Once again, let me try. Now, is it fine? Is it changing?
Ma'am, your screen share has stopped.
Madam, we are unable to see your PPT.
Just a second, ma'am. I'll share the PPTs with you.
Dr. Tabassum, if you can share it to my WhatsApp, immediately we will start sharing it. Don't worry. Be cool. Just share your PPT to the WhatsApp group.
Yeah, ma'am.
Yeah.
Just a second.
Ma'am, is this the slide?
Just a second, ma'am. I'm trying to share one more PPT. Even
Okay.
that I would like to.
Sure, ma'am, sure.
Yes, ma'am. Renuka, ma'am, I shared two PPTs. First one is related to FDP. The second one is related to the normal curve. Okay.
Received, ma'am. Which one do you want us to share?
First one is go to the first PPT, fourth slide. We are supposed to discuss about the fourth slide. After that, we need to move on to the fifth slide. From then onwards, the next PPT we need to move on.
The PPT that I'm right now sharing, is that the one, ma'am?
Yes, ma'am.
So we are going to this slide.
Yes, I'm supposed to discuss about this, not the previous one.
This one.
Yes, the one
Thank you,
which you're pointing out. Yeah, this is the one.
Thank you.
Yes. Yes, the next term which we are supposed to be aware of, statistic. It is a statistical measure computed from the observation alone. When I say statistics, it refers to the measures of the sample. In general, if you observe carefully, I have used different notations for it. For a mean of the population, I have used mu, and for the mean of the sample, I have used x bar. That is the differentiation which you are supposed to make a note of it. Apart from that, for the standard deviation of the population, I have used the sigma, but whereas when it comes to the sample, we use the S as a standard deviation. These are the basic things which you are supposed to be put it in your mind, right? Now moving ahead, next is the theoretical distribution of statistics are called as sampling distribution, and the standard deviation of the sampling distribution is referred as a standard error. Then comes this hypothesis. The hypothesis refers to the general assumption about the population. It is a statement made by an individual in general, and this statement is supposed to be tested by using the procedure called testing of hypothesis. Right. Next comes the parametric hypothesis, that is a statistical hypothesis which refers to only values of unknown parameters of the population, usually called as parametric hypothesis. When I discuss about t-test and all, you will be getting a clear picture what is meant by parametric hypothesis. Moving on, that is the normal curve. Ma'am, could you please open the PPT normal curve and go it in a
Yes, ma'am.
slideshow mode.
Ma'am, you can continue.
Yes, please open that normal curve PPT, ma'am, and share that in PPT mode.
The second presentation, ma'am.
Yes, ma'am. Yes.
Okay, okay, ma'am. Okay.
Yes, let us see what is meant by normal curve. We generally understand what is meant by normal curve. They say that it is a bell-shaped curve where the mean, median, mode lies at the center of it and all those things. How exactly it is constructed, we'll quickly run through. Then moving on, we'll discuss about the types of tests, then the assumption. Suppose we measure the right foot length of 30 teachers and the graph and the results are put on a graph. This is how the graph is going to look. The first person I have taken, I have plotted. This is how it is going to be. Okay, the first person will be having 10 inches. This is where he will be getting. The second person, if I plot the graph, he is having 9 inches foot. The next will be like this. If I go on plotting the graph for all the 30 teachers, somewhat the graph is going to appear like this. Okay, next slide, please. Yes, if you observe carefully, based on this figure, as you can see, how many people are having 10 inches right foot? If you observe carefully, maximum number of people are having 10 inches right foot. But as you move on towards the left side or the right side, if you move on to the right side, the foot length will be increasing. And if you move on to the left side, it will be decreasing. Okay. But if you observe carefully based on this histogram, the number of people having smaller foot length are very less. Similarly, the number of people having larger foot length is also small. If you observe this, any characteristics of a population, like for example, if you want to observe the marks of marks in a subject for a given class of 60 students, like for 100 marks, the people who are getting 90, 95 will be very, very less. Similarly, the people getting less than 40% marks will be very, very less. But whereas the people getting like 60 to 70 marks will be more. That is what somewhat it will be like this, right? Next slide, please. Now what I'm trying to do is take the center points of this histograms and then try to connect them. If I try to connect them, the line would appear something like this. Next, please. And the curve will be, if I smooth the curve, something it will appear like this. Please, next slide. The curve appears to be something like this. I hope now you got it, what is meant by bell-shaped curve and why it is said as bell shape. This is how the shape comes. Whenever you see a normal curve, you imagine something like this, and also imagine that there are certain bar graphs, certain histograms below it, something like this. Okay, now moving on, next slide. Now I'm taking an example of 50 students. If I give a quiz and these are the marks which I got it, and if I plot a histogram, plot a graph, it would be something like this. And the most of, if you observe carefully, most of the people got 17 marks in the quiz, right? And as you can see, the people who got lesser marks, that is 12, 13 are lesser, and people who got higher grades are again few people, very few people got it. Moving on, next slide. Now observing. So already we concluded about the mean. Next, we will see the mode. Mode means most repeated observations. As you can see, 17 is the most repeated observation that falls at the center. That again, it is intersecting with the mean. Next, moving on. A median, that is the central part of this, that is again a 17. If you observe carefully, the mean, median, mode is one and the same in the normal distribution. And these are the various shapes of a normal distribution curves. In general, we assume that the previous one which we saw or something like this only is a normal distribution curve. Not necessary. All these curves are referred as normal distribution curves or bell-shaped curves. The only thing is the difference in them is the difference in their standard deviation, or in other words, the difference in their variance. Here, if you observe this curve and this one is having a lesser standard deviation or a variance when compared to the one which is having a broader one. This is what you're supposed to make a note of it. Moving on, next slide, please. Yes, now coming to the mathematical or the formula part of it. In general, this is the formula which we use for the normal distribution curve. If you pay attention to this formula, somewhere between, you can see x minus mu divided by sigma. X refers to the sample observation, where mu and sigma refers to the population parameters, right? Using this, we try to compute the Z value, and based on that, we will be computing the probability, right? I will not go deeper into the mathematics of it, because assuming that we are more inclined to learn how to apply these tests and what is that, rather than knowing the mathematics behind it, right? For that, we have a software, they can take the help, they are ready to help us out. Right. And one more thing, what you are supposed to remember is the x value, that is, can take from minus infinity to plus infinity. As you go on, these curves will go on extending, but they will never touch the baseline. Yes, moving on. Next slide, please. Yes, now, yes, next. Yes. Now, as you can see that if I take this as the mean, as I said, lies at the center, it is x minus mu means always it will be 0, it will be at the center. For that, if I add plus standard deviation and minus standard deviation, the number of observations should fall under this will be 68.26 observations should be falling under this. Similarly, if you for the x, if you add 2 times of the standard deviation, then what would be the probability or the number of observations which will be falling this? Next slide, please. Yes, as you can see, 95.44% of the observations will be falling within this standard deviation. Right, next one. Now, if I take 3 times of the standard deviation, 99.73 observations will be falling within this. 99.73 means almost all the observations would be falling under this. When I say 1 plus or minus the standard deviation, some of you might be not able to get it, but this I will try to explain with an example. Next slide, please. Yes, this is the normal curve, which is having a smaller standard deviation. The next one, larger standard deviation as the gap is more. Please observe these figures. The same means the mean is one and the same for these 2 curves, but whereas the standard deviation is different. Why? Because this is a wider curve and this is a less wider curve in comparison. As the what do you say, the width increases, the standard deviation also increases. Now let us see this next one. Previous slide, please. Go back to the, yes, different means. As you can see, the first one, the mean is lying here. The mean of the other one is lying at a different place, which means the means are different. But coming to the standard deviation, the width, that is this one. This is one and the same, which is an indication that the means are different, but the standard deviation is one and the same. Now moving on to this curve, if you observe carefully, the mean is different. As you can see, the center point, it describes the mean. But coming to the standard deviation, this is the flatter one. This is the width is little lesser when comparison to this, which means that the mean and the standard deviation both are different for these 2 curves. This is the basic understanding which you should have. Right, moving on. Next slide, please. Yes, now I have taken an example. If the mean of, this is related to number of points that one standard deviation equal to varies from the distribution. On one max test, a standard deviation may be 7 points if the mean is 45. If the mean is 45 means that's the reason it is at the center, and the standard deviation is 7. Then what would be the number of observations which will be falling between 38 and 52? 38 means How did we get this 38? That is the 45 plus the standard deviation. That's the reason. This side it is 34.13. Above mean and below mean. I forgot to focus one point. The mean divides the curve into two equal halves. The number of observation below the mean will be equal to the number of observation above the mean. For that reason, there is an equal portion between or below mean and above mean. Okay, between 38 to 52, the number of students or the number of participants will be, or the number of observations will be, that is 68.26. Similarly, between 31 to 59, that is 2 times of standard deviation, that is plus or minus the standard deviation, right? As you can see, what is the number of observations which will be falling under this? That is again, once again, it is press. Next slide, please. Just press the button. And now, as you can see, one more example I have taken. Next slide, please. Now, this gives the overall picture of the normal distribution, right? If x is equal to mu, the z will be always equal to 0. Please remember, I have applied the formula. Z is equal to x minus mu by standard deviation. Right, back to the previous slide, please. Yes, as you can see, I just explained if the z, if x, z value, if I am moving on, that is, it will be 1. In such case, the number of observations will be 68.26, and now coming to mu plus or minus 2 times of the standard deviation, it is 95.4% of observation. Similarly, plus or minus 3 times of the standard deviation, it is 99.73%. Next slide, please. Yes, next. Now let us see how to identify whether the distribution is skewed. All right. If you can observe carefully, to the left side, the number of observations are less. Is it not, when compared to the right-hand side of the curve, which is an indication that it is left is skewed. Next slide, please. Right, next. Similarly, right skewed. As you can see, the number of observation towards the right are lesser, because of which it is referred as right skewed. Next. Next. Here. Yes, the next. Please stop. Back. Yes, as you can see, if it is a left skewed, then the mean and median would be something like this. If it is positively or rightly skewed, the mean and median location would be something like this. This is the basic understanding which you're supposed to have. Thank you. Going back to the first PPT. Yes, the next step is the testing of hypothesis. I'll just run through this. I don't want to discuss much about it. Assuming that this is an advanced research methodology, assuming that certain basic things or certain knowledge you will be having. It depends upon the textbook which you're going to follow, the steps in testing of the hypothesis. The first one is state the hypothesis. When I say state the hypothesis, you're supposed to state the null hypothesis and the alternate hypothesis. Generally, what we do is we state the null hypothesis, and opposite of that will be an alternate hypothesis. Like, for example, I have taken the marks of MBA first year students, and I just observed it, and I felt that most of the students got 80% of marks, right? I just want to check whether the most of the students got 80% marks or not. For that, what will I do is, my null hypothesis is the average marks of the MBA first year students will be 80%. That would be my null hypothesis, right? So what will be my alternate hypothesis? My alternate hypothesis will be that the average marks of MBA first year students in so and so subject is not equal to 80%. Why I'm saying not equal to? Because when I observed the marks, I felt that most of the students got above 80%. So I just want to check it. That is one thing. The alternate hypothesis can be equal to, not equal to 80% marks. It can be lesser than 80 marks. It can be greater than 80 marks. It again depends. If I'm taking the alternate hypothesis not equal to 80% marks, then it says it is a two-tailed test. If I take lesser than 80% marks, then it says that it is a left-tailed test. Greater than means it is a right-tailed test. That is how it is. Next comes the set the criteria for a decision. In general, we are supposed to check this hypothesis. For that, what you're supposed to do, especially in a t-test, you need to cross-verify with the table value. And to find this table value, we need two parameters. One is the degrees of freedom. The other one is the level of significance. Degrees of freedom, it depends upon the sample size. That anyhow, I'll be discussing while discussing about the problem. Coming to the level of significance, in general, we consider that the level of significance is 5%, right? This 5% can be either increased or decreased. What does this level of significance says is, it in other words, it states about your level of confidence. In other words, it says that if I say level of significance 5%, in 95% of the cases, whatever you're stating will be true. In 5% only, there are chances that it is not true. That is what it says. Especially when you are using this testing of hypothesis related to medical test and all those things, the level of significance will be further reduced to 1% or further. Okay, but in general, while we are doing management research or in commerce, we assume it as 5%. And one more thing is, while using a software, you need not worry about this aspect. You can just focus on the p-value. We consider the p-value as 0.5% and compare this, whatever the value you get, whether it is lesser than 0.5%, or I'm sorry, 5% or not. Based on that, you can conclude, right? This is about the set the test criteria, compute the test statistic that is based on the data you have, based on what is that you want to conclude and what is that you want to test. There are various tests available. You can apply any of them and accordingly compute the statistics. Then make a decision. That is, you make a decision whether you are going to accept the null hypothesis or not. In general, we say that we are supposed to say that H0 is rejected or we fail to reject. Okay, if it is if the p-value, in general, since we use a software, based on the software, we check with the p-value rather than the calculated value and the table value. So if it is lesser than 5%, we say that it is significance. In other words, we say that we accept the alternate hypothesis. In other words, we say that we reject the null hypothesis and vice versa. But in general, the statistics, whenever you're applying to be more precise, you're supposed to say that H0 is rejected or we fail to reject the H0. That is what we are supposed to say, rather than accept null hypothesis or reject null hypothesis or accept null hypothesis, accept alternate hypothesis or reject alternate hypothesis. Next slide. Yes, these are the various parametric tests available. I've just listed out few. The first one is one sample t-test. In general, in this one sample t-test, we are going to use only one sample. And with that sample observation, we try to make certain conclusions, or we try to make certain inferences, right? Coming to the unpaired two sample t-test, that is, the test is performed to compare two means of two independent samples. Like, for example, if I have two sections of MBA, I want to check whether the marks of the two sections are one and the same. In such case, I'll be drawing 10 students from section A and 10 students from section B and try to compare their averages and accordingly make a decision. Next comes paired two sample t-test or simply a paired test. In general, in this paired sample test, what you're supposed to do is you have to take the record the observations before and after. For example, like you have given certain training program to your employees to improve their performance. Okay, right. In such case, you want to check whether the training program was effective or not. To do that, what you will do, you will measure the performance of, you will select a sample, let us say 10 employees. You measure their performance before their training program. Make a note of it. Then give a training program for 1 month or whatever it is. Then after the training program, once again measure their performance. Then you check it out. Is there any difference or not? If you see there is a difference in their performance, then you conclude that the training program was effective. That is what we do in a paired t-test. Then comes ANOVA. In general, in ANOVA, what we do is we try to compare the means of 2 or more groups. When it comes to two sample t-test, we can use only 2 samples, or in other words, we can use only 2 groups. But if the groups are more than two, in such case, how do you compare? Like for example, in this 2 sample t-test, is there any significant difference in the, based on gender, is there any difference in the performance of the employees? Genders are only 2, that is male and female. These days, when you're doing a research, the gender is not confined to only 2. The third one, that is, you can even ask, I reserve to say or communicate, the third gender also. Or in other words, age groups. If there are 3 age groups, like 20 to 30, 30 to 40, 40, above 40. If you want to see that whether there is a significant difference with respect to age groups in the performance of the employees. Since there are 3 groups, I have to use ANOVA. I cannot use this one, 2 sample t-test, right? We use ANOVA. Coming to the ANOVA, there are again 2 types, that is one-way ANOVA and two-way ANOVA. In one-way ANOVA, we try to check the influence of only one factor. But whereas when it comes to two-way ANOVA, we check the influence of more than one factor, that is 2 or 3 factors. Okay. Maybe little later when I'll be sharing an example, you will understand better about it. These things, the Pearson correlation coefficient and z-test, I would like to avoid because of paucity of time. Moving on, next. Next slide, please. Yes, these are the test which I have discussed or referred as parametric test. Before going for this slide, I just want to throw some light. Yes, there is a question from somebody, Shireen. What is a paired and unpaired test? See, in a paired test, the observation is recorded from the same sample. As I said, if I want to check the whether the training program is effective, I have first, before training program, 10 employees I have chosen. The same 10 employees after the training program, I have to take their observation. In other words, I have to take their performance analysis. Based on their performance, I will be comparing. Means the same one. In general, it is said that dependent t-test, paired t-test. But whereas in the other one, 2 sample t-test, it can be 2 groups, any 2 groups. The 2 groups can be the same sample is not used. Here a different sample, there a different sample. As I said, in the first sample can be related to the males and the second sample can be related to females, right? That is the difference. Yes, somebody is asking, please repeat when to use t-test and ANOVA, right? Generally, t-test can be used either for 1 sample or 2 sample. Okay, based on the name itself, single mean means a single sample can be used. 2 means 2 groups you can use. As I said, when there are more than 2 groups, like for example, if you want to check whether there is a difference in the performance of the employee with respect to the cadre. Cadre means, let us assume there are 3 cadres in your organization, cadre 1, cadre 2, cadre 3. Okay, there are 3 groups, isn't it? Each cadre is referred as one group. If I want to check whether cadre wise there is a significant difference in the performance of the employee. As there are 3 groups, I cannot use this one, 2 sample test, sample t-test. There I have to go for a ANOVA. Why? Because I am having 3 samples, or in other words, I am having 3 groups, right? Shall I move on? Any more questions? Yeah, somebody is asking, does the sample size affect the choice of ANOVA? Generally, what we say is for this ANOVA and what do you say, t-test, they are considered as small sample test. But as we increase the sample size, we need not worry about the sample size. That is taken care by the this one, what do you say, by the software, because as the sample size increases, the table value changes. So that is taken care. You can proceed with either a small sample or a large sample. That is not an issue, right? Moving on. Yes, I was supposed to say what is meant by parametric test on non-parametric test. I'll take the questions at the last, because once if I start addressing all the questions, I cannot move ahead. Please keep your questions last 10 minutes or 15 minutes, right? Because continuously I'm getting questions. Is it okay, ma'am? Renuka,
Yes,
ma'am?
ma'am. That is what we usually do, ma'am. You can take the questions in the end, ma'am.
Right. Thank you, ma'am. Yes. Let us see what is meant by parametric test or non-parametric test. While using parametric test, as I said, parameters means mean, median, this mean and standard deviation. Generally, we take this. Not only that, these parametric tests are based, whenever you want to apply, there are certain assumptions related to it. If these assumptions are fulfilled, then only you can apply this parametric test. And if it is not so, you're supposed to go for a non-parametric test. That is one thing. Apart from that, in general, when it comes to parametric test, we use the sample or the data which we are going to collect related to the sample should be measured either on an interval scale or on ratio scale. Then only we can use parametric test. But whereas when it comes to non-parametric test, the data can be measured on either a nominal scale or a ordinal scale. Right. I hope you are aware of what is meant by nominal scale, ordinal scale, interval scale, and ratio scale. Right. So moving on, let us see when the parametric tests are applied. What is the test to be applied and what is the non-parametric test to be applied? Yes, I'm going to share the PPTs, both the PPTs after the session. Not only that, I would be sharing a study material related to that, which is very, very elaborate and which is self-learning part. With using SPSS, it explains all, or it tries to explore all the assumptions, right? I'll share it with the resource, with the coordinators of the FDP. In turn, they will share it with the participants. Yes, moving ahead. If you want to compare the means between independent groups, then what you're supposed to use, 2 sample t-test in parametric test. If the assumptions of parametric tests are violated, then you're supposed to go for a non-parametric test. An example also I have given. Do managers who are men have higher average salaries than managers that are female? In other words, I'm trying to test here. What do you say? The hypothesis seems to be little complicated. I can say that in a simple words, the average salaries of male and female do not differ significantly. I can say, right? That would be in a simple way. Similarly, now coming to a paired t-test, compare two quantitative measures taken from the same individual. Please make a note here, it is the same individual before, after you're trying to measure it. If it is a parametric test, use a paired t-test. If not, you can go for Wilcoxon signed rank test. The example is examine students' diagnostic test result before after a unit of study. What is the performance? Is the performance has improved or not? If you want to check it is improved or not, then you are supposed to use a paired t-test. And remember, you are using the same sample or the same individuals. Right. Next comes compare the means between 3 or more independent groups. Right. That is, as I said, until 2 groups, t-test will serve the purpose. If the groups are more than 2, you are supposed to go for ANOVA. The example, is there a difference in crop yield if a farmer uses fertilizer A, B, or C? As you can see, if there are only 2 fertilizers, he can go for this 2 sample t-test. Since he is having more than 2, that is 3 fertilizers, he is supposed to go for ANOVA. That is in parametric test. In non-parametric test, he can go for the Kruskal-Wallis test. Similarly, this I just want to skip because it doesn't fall under our scope of discussion. Again, the association between 2 variables, here we use normal Pearson correlation, and here we use a rank correlation. The name itself says the data is measured using the ordinal scale, that is rank, but whereas here we use normal either on an interval scale or on a ratio scale, right? Example, you can say, does the number of hours a person spends on a social media affect the number of hours they sleep at night? In general, how they are related. Are they positively related or negatively related? We can conclude. Moving on, next slide. Next slide, please. Yes, I think it is the same one. Please, next. Yes. Now we are moving to the t-test. That is, it is referred as student t-test. It was developed by W.S. Gossett, 1867 to 1937. He worked for a research institute where he is not supposed to give his name, because of which he used anonymous name, that is student. Under that, he has published this t-test, right? As I said, there are 3 types under it: 1 sample t-test, independent 2 sample t-test, paired sample t-test. Next slide, please. These are the assumptions of it. How to check the assumptions, we'll see in the last. The parent population from which the sample is drawn is normal. So whenever you're trying to test the hypothesis, you're supposed to draw a sample. Based on that sample characteristics, you will conclude the population characteristics. So whenever you're drawing, the assumption is normally distributed the population. As we all know that in general, the population will be normally distributed. Like for example, marks of the student. You can see either students getting very low marks or very high marks will be very, very less. But number of students getting average marks will be more. These are the certain characteristics of a normal distribution. In general, it happens. Like for example, height of a student. Very tall students or very short students, very difficult to find, or rather you can say very few students will be there in the class, right? The sample observations are drawn randomly. One of the very important characteristics or the condition which you are supposed to fulfill whenever you're drawing a sample from the population is the sample is supposed to be drawn randomly. This aspect can be taken care by using random sampling methods. As you people might be aware that there are 2 types of sampling methods, random sampling method and non-random sampling methods. based on certain conditions and certain limitations of the researcher, they will follow either a random or a non-random, but it is generally advised to follow a random sampling method. Any of the random sampling methods, either a simple random sampling method, either stratified random sampling method, any method you can follow based on your convenience. The next is population standard deviation is not known. So if you observe carefully whenever you're trying to do a research, that knowing the standard deviation of the population is very, very tough. If you are aware of the standard deviation of the population, then you will go for a Z test. Since we are not aware of the standard deviation of the population, that is sigma, we go with the T test, and we use S as a representation for that, and accordingly we can move. Next slide, please. Yes, this is again, I think, very much similar to the previous one. The only thing in this which I want to discuss is the last one, that is the degrees of freedom. As I said, if you want to calculate if you want to find out the calculated value, as I told you, we need degrees of freedom. For a one sample t-test, the degrees of freedom will be n minus 1. For two sample test, n1 plus n2 minus 2, because n1 refers to the size of sample 1, n2 refers to the size of sample 2 minus 2. And coming to the paired t-test, it is just n minus 1. Please remember, in a paired t-test, it is only one sample which you are going to measure. That is before and after, because of which it is only n minus 1. Right. As you know, degrees of freedom refers to the number of independent observations you can consider. Next. This is just for your information, the pictures of William Gossett. Moving on. Yes, generally we use this formula for testing of T statistics as a single sample. X bar refers to the mean of the sample, mu refers to the mean of the population. S refers to the standard deviation of the sample, and N refers to the sample size. Next slide, please. Yes, once again, I just want to, I think we can skip this. Yes, this is an example which I have previous slide. To test a single mean, with this you will get a better understanding when to use a single mean. The closing price of an XYZ share on different days in a month found to be as follows. Discuss whether the mean price of the share given a month is 24 rupees or not. These are the samples which each day closing price I have recorded, and these are the observations. For this now I am supposed to apply a t-test. If you observe carefully, what does 24 refers to? 24 refers to mu. And using this data, this raw data, you are supposed to calculate what will be X bar and what will be S. N is already given, or just count the number of observations, you will get it. Next slide, please. As you can see, the N is 20 because 20 observations. I have computed X bar, that is 21. I think yesterday's resource person has covered this, how to calculate the mean and the standard deviation of the sample in descriptive statistics, right? Now, stating the null hypothesis, the mean share price of XYZ company is 24. That is, the sample mean is equal to population mean. If you observe carefully, is the mean is one and the same? What is the mean of the population? It is 24. What is the mean of the sample? It is 21. How can you say that it is same? Because by observation itself, it is saying that it is not same, right? Actually, why are we are doing this test is whether the differences is because of sampling error, or whether the difference is significant or not. Generally, we also use this word test of significance. Is it not? Test of significance means whether there is a significant difference or not. By observation, yes, it is saying that there is a difference, but whether this difference is significant or within acceptable limits or not acceptable. For that reason, we are doing this testing of hypothesis, right? And now apply substitute those values in the formula, then find out the values, then you will get it. That is the table value you will be getting using degrees of freedom with 5% level of significance, and the calculated value you will be getting. Generally, this is the criteria which you will be doing. If the table value is lesser than the calculated value, you reject H0. And if it is greater than, you will be accepting H0. Right, next. Yes, I have written here what will be the table values and the calculated values. As you can see, it is minus 2.30, and accordingly, since you can see it is it greater than or equal? It is greater than. For that reason, what are we concluding? The mean share price is not 24 rupees, right? Since it is the calculated value is lesser than the table value, we are concluding the mean share price is not 24. It is more, right? Next one. This is the table values based on which you can compute. As you can see, as I told you, based on the alternate hypothesis, either it can be one tail or two tail.
Pardon me, ma'am, your voice is going very low in between.
Now, ma'am?
Now it is better, ma'am.
Yes. One tail test means the rejection region lies at only one side. Two tail test means the rejection region lies at two sides. If it is one tail test, the level of significance is 5%, means it will be having 5%, all the 5% at one single side, either left or right. But when it comes to the two tail test, that 5% is divided by 2, alpha by 2 and alpha by 2. Generally, it is denoted by alpha. As you can see, based on this is one tail, two tail, based on the level of significance, you can check. This is the degrees of freedom. 1, 2, 3, 4, based on the sample size. Based on that, you can compute or you can find out, identify the table value, compare it with the calculated value, and accordingly make a decision. But in general, this is not required, because whenever we are doing a research, we take the help of the software. While using a software, we don't go by this calculated values or table values. Rather, directly we compare with the P value. That is the probability, whether the P is lesser than 5% or not. Or in other words, if we are using a level of significance 1%, we check it whether it is lesser than 1% or not. Based on that, generally we make a conclusion. If it is lesser than the level of significance, we say that there is a significant difference. If not, we say that there is no significant difference. Moving on, next. And this is what I was just saying. Just move on. Now, two sample t-test. Back. Yes, this is one example I have taken. A group of 5 patients treated with medicine A. Weight is 42, 39, 48, and 60 and 41 kgs. In the second group, 7 patients are there from the same hospital treated with the medicine B. The weights are given there. Do the two medicines differ significantly with respect to increasing the weight of the patients? Generally, the medicine which we are checking A and B, they are meant to increase the weight of the patients. Whether please remember one thing, we are trying to check whether there is a difference in the medicines with respect to increase in the weight of the patients. That is what we are trying to check. So for this, as you can see, medicine A, medicine B. Medicine A, the people who have to whom we have administered medicine A is referred as group 1, and the people who have been administered medicine B, they are referred as group B. Whether there is a difference in these two groups with respect to this increase in weight because of this medicine, we are trying to check. Right, moving on, next slide. Yes, coming to the null hypothesis, there is no significant difference in medicine A and medicine B with respect to increase in weight of the patients. Mu1 and mu2 is equal. That is, mu1 refers to medicine A, mu2 refers to medicine B. Alternate hypothesis, there is a significant difference in medicine A and medicine B with respect to increase in weight of the patients. For that reason, I have taken not equal to. Here, if you want to take, you can take greater than or lesser than. Then if you take either greater than or lesser than, it will become a one-tailed test. This is not equal to we have taken, which means that it is two-tailed test. Now, as you can see, x1 and x2 refers to the means of sample 1 and sample 2. Sigma 1 and sigma 2 I'm sorry, it should be S1 and S2, not sigma. It should be S. And N1 and N2 refers to the sample 1 and sample 2. Moving on. Next slide, please. Yes, I think the results are in the Excel sheet. It is not here, but it's okay. As you can see, I've computed the mean and the standard deviation. And this mean and standard deviation, if you compute and then substitute in the formula, then you will be getting the results. As you can see, what is the table value? The degrees of freedom can be calculated as 10 because 5 plus 7 minus 2, it is 2.228. Since the Excel sheet is with me, we can just proceed with it. This implies that there is evidence that there is a significant difference in medicine A and medicine B. Maybe if you compute project the calculated value on the table value on the figure, then maybe it falls under rejection region, right? For that reason, we have rejected. Previous slide, back. No, stop. Move on, front. Next. Yes, now let us see paired t-test. Paired t-test, as I said, suppose we want to test the effectiveness of the program designed to increase the scores on the quantitative section of the graduate GRE test. We test the program on a group of 8 students. Prior to entering the program, each student take a practice quantitative GRE exam. After completing the program, that is the training program, each student takes another practice exam. Based on their performance, we will check whether the program is effective or not. Please remember, the same 8 students were measured before and after the training program, right? Next slide, please. Yes, these are the 8 students. The results are shown on the screen before the program, after the program, what is their score is given here. For this, we are supposed to compute the whether there is a difference in the performance. If there is a difference in the performance, then we conclude that the training program is effective, right? Moving on, next slide, please. I have computed the difference between the scores. Next slide. What I'm trying to say is the null hypothesis and the alternate hypothesis. Alternate hypothesis, the program is effective. That is, the scores program will be higher than the scores before the program, right? So what I'm trying to do, UD refers to the difference between before and after. If the difference is less than or equal to 0, means there is no improvement in the performance. If UD is greater than 0, means there is an improvement in the performance. If the score is 1 and the same before and after, obviously the difference will be 0. If the score is improved after the training program, then obviously the difference will not be 0. For that reason, the null and the alternate hypothesis is taken as follows. That is, mu d is less than or equal to 0 and mu d is greater than 0. Next. The difference, this is only computational part, skip. Next. Next. This is only the calculation part. I just want to skip the calculation part. Yes, previous slide, please. Previous one. Back. Yes. Now, as you can see, I have calculated the t value. I got it as 2.714, and the table value, I got it as 1.897. As the calculated value is greater than the table value, that is 1.895, I reject the null hypothesis and I conclude that the program is effective. In other words, I'm concluding that the performance of the students has improved based on the training program, right? There is a difference in the GRE score of the students before and after the training program. Next slide. This is for table value. Next. Yes, in general, we will see T is a measure of how difficult it is to believe the null hypothesis. High value of T means, what does it say? It says that difficult to believe null hypothesis. In other words, we are supposed to accept that there is a real differences. The differences either in the groups or either in the population or the sample, or the difference before and after, there is a difference. But if the value, T value, that is the calculated T value is low, then it is easy to believe the null hypothesis. In other words, you are saying that you have proved that there is no difference before and after, or there is no difference in the groups, or there is no difference in the sample and in the population. Right, next one. The conclusion, when a sample size is small, based on the situations, that is to compare a single sample mean with the population mean, we use a single mean t-test. To compare the sample means of two independent samples, there is a typo error, t is missing there. We use two sample test. To compare the sample means of paired samples, that is before and after, then we go for a paired t-test. Next slide, please. Next is ANOVA. As I said, a one-way analysis of variance is used to test the claim that that three or more population means are equal. The limitation of two sample t-test is you cannot use more than two. But in general, whenever we are doing a research, we tend to test between more than two groups. In such case, we can take the help of ANOVA. In other words, this is extension of two independent sample t-test. ANOVA is an extension of two sample t-test. Next slide, please. Generally, when it is applied, we will just see. The response variable is the variable you are comparing. Like, for example, let us say that the factor variable is categorical variable being used to define the groups. And we can assume there are k samples, that is k groups. Let us say that age-wise, age group-wise, there is a significant difference with respect to the performance of the employee. If I say age group means group 1 is, let us say, below 25 years. Group 2, let us say 25 to 35, and group B is above 35. I'm dividing them into groups. Actually, age is a ratio scale variable. But what I'm doing, I'm trying to convert it on the nominal scale by converting into a group. The moment I convert it into a group, it becomes a nominal scale. So, which means that it is a factor, whether age is influencing the performance or not. Performance, again, it is measured. Generally, how do you measure the performance of the employee? Especially whenever you're doing a research, you will give him certain set of questions like Maybe if you are using a standardized scale, you administer that. A set of questions will be there, and for each question, you will be giving a Likert scale. Based on that Likert scale, 1 to 5, either 5-point scale or 7-point scale, you will be measuring. And based on that, the total score, summated scale, we say, for each item or for each question, you will compute the score based on the response, and you add up, and whatever the score you get it, that is referred as the performance score. And this score, since it is measured on an interval scale, you can use ANOVA. One is on interval scale, the other one is on nominal scale. Actually, the age is also not a this one nominal scale, but we convert it. For example, race, different race, different ethnics. You cannot say one is superior to the other and so on. Like colors, red, blue, green. You cannot say one is superior to the other. Each one is different. Just you differentiate or you use it for categorization, right? So that's how it is. One variable should be on a nominal scale. The other variable should be either on a ratio scale or interval scale to use ANOVA. That is what I would like to say. Next, moving on. Next slide, please. As I said, since more than 2 groups, mu1 is equal to mu2 is equal to mu3 is equal to mu of k, depending upon the number of groups. The alternate hypothesis will be not equal to. Please remember, in ANOVA, we cannot use two-tailed test. It can be only not equal to. Next slide, please. I have taken one example. The statistic classroom is divided into 3 rows, front, middle, back. The instructor noticed that further the students from him, more likely they were to miss the class or use an instant messenger in the class. He wanted to see if the students, farther they did worse in the examination or not. This is an example I have taken. Move on to the next slide. Yes. Yes, this is the null hypothesis and the alternate hypothesis. As you can see, this is front. UF refers to the average mean of the front row. UM refers to the mean of the middle row. Mu B refers to the mean of the back row. Instead of 1, 2, 3, I have given based on the example. Right, next. This is the sample I have taken. Random sample of students in each row was taken. Front row, middle row, back row. Now I am supposed to check the apply ANOVA and check for the results. Next, please. This is what I got the statistics or the observations, mean and standard deviation and variance. Next. The degrees of freedom I'm supposed to calculate. In general, as I said, it is right tail test because we are using variance. Variance will be always positive, never it will be negative. For that reason, it will be always a right tail test. And here what we do is, in general, whenever we are using this ANOVA, we try to check it out whether the between groups and within groups, the variance between the groups and within groups, we are going to check. Based on that, we are trying to conclude. If the variance between group, the ratio of, please make a note of it, the ratio of between variance of between groups and within groups is greater, then we conclude that there is a significant difference among the groups. The point to be noted here in ANOVA is which group is having higher mean, that we cannot conclude. If we are using 3 groups, even if one group is not having the same means as the other, or in other words, there is no significant difference, it will conclude that there is a difference. It's not necessary all the 3 should not be equal. If any one is also not equal, it will conclude that there is a difference in the groups. That is one limitation which you have. And this limitation can be addressed by using post hoc test. Yes, moving on. And this is the table, ANOVA table, which you will be getting once you run either using an Excel or SPSS. The focus should be on this F. This is the calculated value, 5.9, and this is the table value. And this is the value which you get. Actually, even the P value, you are going to get it. Based on that also, you can make conclusions. As you can see, it is, next slide, please. The P value, here I have taken P value. Moving on. Next. There is enough, next. Back. I think it is in the Excel sheet, that's the reason. Back. Yes, based on this only we will try to do. The table value, as you can see, it is 3.467. This is the calculated value. Since the calculated value is greater, what we do, we reject the null hypothesis and accept the alternate hypothesis. Next. And what is the conclusion we are going to draw? Next slide. Back on. There is an enough evidence which is less than the significance value. We reject the null hypothesis. Actually, as I said in the beginning, we are supposed to say what we are supposed to say. H0 is rejected or we fail to reject. We cannot say reject the null hypothesis, accept the alternate hypothesis, and so on. Next. This one, please make a note. There is a difference, we said, but difference among which group we don't know. Either for that we are supposed to use post hoc test, either two-key test or Bonfermi test. There are many tests available based on the conditions, certain conditions each test has. Whichever is nearly satisfying, you can test the post hoc test and conclude which one is having a significant difference. Or if not, you can use, for example, there are 3 groups. So first and second you check, second and third you check, then first and 3 you can check by using a simple t-test. But t-test you are supposed to use thrice there to check the difference. But after post hoc test, if you want, you can use the independence 2 sample t-test also if you want. Next. Now comes to Way Anova. I'll just try to explain the concept, and I want to discuss about the assumptions, which is the focus of this session. Next one. Yeah, as I said in Way Anova, what we are supposed to do, we are supposed to study the effect of 2 independent variables or 2 independent factors on 1 dependent variable. If you see the question, you will understand better. Moving on, next slide. Next. In general, yeah, these assumptions will get back to later. Next slide. Next. Yes, please stop. See, there are actually in Way Anova with replication, without replication also we can use. With replication, the sample size should be 1 and the same. If it is not same, we cannot apply. I'll tell you the difference because both the topics I'm trying to handle right now itself within 5 minutes. Next, moving on. Yeah, this is the question which is given to us. What are the 2 factors which we have? One factor is salesman, the other factor is seasons. If you observe carefully, I have chosen 10 salesmen, and what are their monthly sales in each season I have recorded. A company sales in 3 seasons, summer, winter, and rainy. The owner decides to see whether the sales representative and the seasons affect monthly sales or not. These numbers represent the monthly sales. Whether the seasons, that is summer, winter, rainy, is having effect on this sales or not is the one hypothesis we are going to test. The second hypothesis we are going to test is the salesman. Whether the salesman differs significantly with respect to this one, or the effect of the salesman is there on the sales or not, we are going to check. At alpha is equal to 5%, that is level of significance, analyze using two-way ANOVA. Sales are given in hundreds of dollars for a randomly selected 10 salesmen. Next slide. As I said, two hypotheses. Why? Because two factors. One for the salesman, one for the seasons. Okay. Generally, they say rows and columns since it is represented in rows and columns. First one is there is no difference in the salesman with respect to sales. And the alternate hypothesis, there is a difference in the salesman with respect to sales. This is for the rows and this is for the columns. For the columns, column-wise, what is the factor we are representing or what is the variable? We are representing seasons. So for that reason, there is no difference in the seasons with respect to sales. There is a difference in the season with respect to the sales. Right, moving on. Next. Next slide, please. This is the output of two-way ANOVA. As you can see, as I said, the p-value also is computed by the software. But in general, when we are doing manually, we check this f value with f critical value. If not, you can directly check with the p-value. As you can see, the p-value is much greater than the 5%. In both the cases, you can conclude that there is no significant difference. In other words, seasons are not influencing the sales and salesmen also are not influencing the sales. That is what we conclude based on the p-value. Next slide. Now we will say two-way ANOVA with replication. Next slide. When I say two-way ANOVA with replication, what we do is we try to check the interaction between the two independent variables also. Okay, actually it is an extension of two-way ANOVA. The researcher is able to test the effects of two independent variables or the factors on one dependent variable. Next slide. Next slide. Now, if you observe carefully, in two-way ANOVA, we had only two hypotheses, right? But whereas in this with replication, we have three null hypotheses. One for each independent variable, since there are two independent variables, two hypotheses for that. For the interaction one, that is the effect of together both, that is the interaction, one more hypothesis for that. This you will get a clarity once you see an example, which I'm going to discuss right now. Next slide, please. Yes, this is the question given to us. A company sells three items: swimming pools, spas, and saunas. The owner decides to see whether the age of the sales representative and the type of item affects the monthly sales. This is the level of significance. He is asking us to use two-way ANOVA. Sales are given in 100, randomly selected, 5 sales representatives selected from each group. This is the first factor, that is the age group we have taken, that is over 30 and under 30, right? Next one is next button, next press the button, you will get it. This is the column heading, that is the items. What are the three items? Pool, spa, and sauna. These are the three. One hypothesis for this items, one hypothesis for the age group. Next one. The other hypothesis is together. Next. Yes, these are the three hypotheses which we are getting. One is for the, we'll go directly to the hypothesis. Next slide. Next. Press. Yes, the first one, as you can see, there is no difference in the means of the monthly sales with respect to age groups. Here we are trying to check age group influence on the sales. First null hypothesis is done. Next slide, please. Next, that is the second hypothesis. That is now we are trying to check with respect to the items. There is no difference in the means of monthly sales with respect to the type of the product. Whether the product is influencing the sales or not, we are checking. That is the second factor we are checking. Next. Yes, there is no interaction effect between age groups and the products sold on the monthly sales. That is, maybe some people can say that younger people have better sales with respect to sauna or spa or something like that. For this, I will try to take one small example and explain this interaction where you can understand better what is meant by interaction. Like for example, if I want to check the sweetness of tea, the sweetness of tea is generally influenced by the number of teaspoons of sugar you are going to add. So now what I am using one more factor, the sweetness of the tea will be increased even by stirring. That is, it is not necessary just if you add a sugar, the sweetness will increase. It also depends upon stirring with a spoon, isn't not? The first one, if I say if you're stirring with for 5 seconds, what will be the sweetness? For 10 seconds and 15 seconds. The more you stir, that is, let us assume 15 seconds if you stir, the sweetness will be more. If you add 3 tablespoons, but only 5 seconds if you stir, what will be the effect on the sweetness? It may not be that sweet, isn't it? In other words, the number of tablespoons of sugar added to the tea and also the number of seconds you stir the tea will increase the sweetness. In other words, the number of spoons of sugar and the number of seconds you are going to stir also influences. In other words, there is an interaction between the two factors, right? Moving on, next. Hello, I'll call you back. Yes, this is the data. Next. Next. This is just an Excel. We'll go to the results. Next. Yes, these are the results. If you observe carefully, for each group, the averages, the variance and the sum is given. This is the total. And this part is the part which you are supposed to focus, the ANOVA table part. As you can see, sample, column. Sample means it refers to the rows, it refers to the columns. This refers to the interaction. As you can see in the previous two-way ANOVA, we never had this interaction part. Only these two were there. Here, the interaction also is significant or not, we are going to check. If you observe based on this P value, it is not significant. That is, the products are not significant, but age-wise, there is a difference, and also the interaction, there is a difference. Next slide, please. Yes, as you can see, these are the values. This is lesser than 0.05. This is also lesser than 0.05. So there is a significant difference. We can say here it is greater than. So we say that there is no significant difference. If you want, you can check with the critical value, that is calculated value, and table value also. And accordingly, you can draw the inferences. Moving on. Yes, these are the results. Accordingly, the conclusions are drawn. Not rejected, rejected had 0, and for the interaction also we have rejected the null hypothesis. The hypotheses are written next. These are the inferences. There is no difference among the mean sales between the two age groups. There is a difference among the mean sales between the different products. There is an interaction effect between ages and the salespeople and the products they sell. The combination between age group and the salesman and the type of product they sell affect the monthly sales. Together, both also are affecting. Individually, age is not affecting, but individually product is affecting. But age and product together also is affecting the sales. Next. Yes, now the core part of it. As I said, this parametric test, there are certain basic assumptions, right? What are those assumptions? We will see. The first assumption is normality. That is, the sample data come from a population that is approximately follows a normal distribution. This is one characteristic. Each one we are going to address. Okay, next is previous one, back. Next is homogeneity of variance. The sample data come from the population with the same variance, right? Coming to the two sample t-test, if the variance is different, there is one more test. If the variance is one and the same also, there is one more test. Okay. Next is independence. The sample data consists of independent observations and our samples are drawn randomly. But paired t-test, the condition itself says that it should be dependent. In such case, this condition need not be satisfied. Next is outliers, that the sample data don't contain any extreme outliers. Next.
Pardon me, ma'am, your volume, ma'am.
Yeah, I'll just conclude within 10 minutes, ma'am, maximum. I'm sorry to extend.
It's okay, ma'am, no issues.
Next slide, please. Yes, how do we check normality? So for that, we are trying to discuss. For that, we have Shapiro-Wilk test and Kolmogorov-Simron test. These are the two tests which we have. In general, both they tend to apply, but the condition is the first test, that is Shapiro-Wilk test, can be applied if the sample size is less than 50. If it is large samples, means you can go for a Kolmogorov-Simron test. So whenever you're testing these two hypotheses, you have to make a H0 and H1. The distribution is normal. In general, the assumption we say that H0 is normal. And what is the alternate hypothesis? The distribution is not normal. So for the sample, just run this two test and check with the p-value. If the p-value of the test is lesser than the certain level of significance, as I said, generally accepted one is 5%. If the p-value is less than 5%, then the data is likely not normally distributed. If it is less than 5%, then you say it is not normally distributed. If it is greater, you can conclude that it is normally distributed, right? Now, if the sample sizes are large, very large, either you can use this case Kolmogorov-Simron test, or if not, you can go for this QQ plot. I think maybe in tomorrow's session where charts are discussed, sir will be discussing about this. Just draw the charts, make an visual observation. If it is all the points, observed points are falling on that straight line, then you conclude that it is normally distributed. If not, you say that it is not normally distributed. If it is not normally distributed, so one choice you have is using transformation for normality. Whatever the data you have, you can transform the data. But certain times when you transform the data, the characteristics of it will be lost. For that reason, certain times it is not advised. Okay. Then in such case, what you are supposed to do? In such case, if this assumption is violated, you can go for a non-parametric test. As I told you, we always have non-parametric test for our rescue, because the non-parametric tests are considered as distribution free. So here, any test which you want to apply in parametric, we assume that normality exists. But whereas in non-parametric, that assumption is not required, because of which we go for non-parametric test. Next one. Next slide, please. Yes, if you are using a transformation, these are the two transformations if you can use. If it is positively skewed, you can take the log of the data of the observation and accordingly proceed further. If it is negatively skewed, you can take power of that observation and accordingly proceed. But please remember, certain times the characteristics are lost whenever there is a transformation. You have to be very careful while applying it. Next slide, please. Then comes homogeneity of variance. That is, the sample data come from a population with the same variance. Since you're trying to draw two samples, whether the variance will be same or not, you're not sure of it. But if you want to apply, the variance should be one and the same. In such case, what you can do is, one thing is you can go with the thumb rule. Okay, what is the thumb rule says? The ratio of the larger variance to the smaller variance is less than the 4. Two samples you have taken. Compute the variance of that. Compute the ratio of those two variants. That is larger divided by smaller. If it is 4, then what you can say? Then we can assume variances are approximately equal and use two sample t-test. Okay. If not, what you can do, this is an example where I have shown a sample 1 variance is 24.5, sample 2 15.2. Then the difference is 1.61. Here it is lesser than 4. So we can say that there is no, there is a homogeneity of variance, right? If not, one more way, this is a thumb rule. There is a Levin's test. The Levin's test, what it says is, the null hypothesis, no difference in the variance. That means there is a homogeneity of variance. The alternate hypothesis is difference in variance. Compute the Levin's test value, compare it with the level of significance, and accordingly conclude. Even if it is violating homogeneity of variance, then again, for our rescue, we have a non-parametric test, that is Welch test. This is the one you can apply. Next one. Next one is run to check the randomness. This randomness can be checked by whenever you're trying to select the sample. If you follow strictly the random sampling methods, automatically you can conclude that there is a randomness in it. If it is not so, what you can do is you can use this run test. Okay. Not only that, you can with this you can check it. The next one is identifying the outliers. This outliers, what you can do is you can use a box plot. In the box plot, here I haven't shown it. I did not focus on these things because anyhow tomorrow a resource person will be focusing on these things only because it will become a repetition. So I did not put it on the slide. Which shows the median, which reflects the quartile deviations, which shows the outliers, means which are extreme points. In general, the outliers come into picture whenever you're trying to feed the data. Like if you, while typing 22, if you type one more 2 extra, it will become 222. Sometimes you miss out. When you draw this box plot, you can check this outliers. They can be identified by using points. Based on that, you can remove one by one and accordingly you can proceed. And one more assumption is independence of observation. There are various tests for that, you can use it, but in general, this Durbin-Watson test, you can apply. And if it is -2 less than or equal to Durbin-Watson test or less than, then we can assume that there is no first order linear correlation in the observation. In other words, it should be falling between plus or -2 to accept that there is linearity. And in other words, there is an independence in the observations. Next slide, please. These are the assumptions of t-test. I told you to skip, isn't it? Right now we are trying to discuss. Data should be free from the outliers. Check it with a box plot. Data obtained on independent variables must be metric. That is either you're supposed to use interval scale or ratio scale. So when you want to apply itself, you will check. Rather, it is not an assumption. It is a condition which you are supposed to check it out. Independence. This either you can use a test or either you can go for a Durbin-Watson test you can do, or while selecting the sample, if you check that the two samples, the first one and the second sample are independent, then also you can do it. For randomness, as I said, while selecting the sample, strictly if you follow any of the random sampling methods, you will stick or you will satisfy this condition. If you are doubtful, use a run test. Normality, again, you can use any of this test, or if not, just this graph in SPSS, if you can use, that also will tell you to very great extent whether it is normally distributed or not. Next. These are the assumptions of the ANOVA, which we have discussed just before. Right, that's it. Thank you. Yes, please, any questions you can ask me?
Yes, thank you so much, ma'am, for that wonderful and a very detailed presentation on
But
the.
I'm so sorry, ma'am, for extending the
That's
timing.
okay, ma'am,
Because
but
of
I guess
initially technical hiccups, I had to extend. I'm so sorry about it.
no problem, ma'am. I think we will invite a few questions, and participants who want to ask questions are most welcome. You can unmute yourself. Any questions from the participants?
I think while I was discussing, there were many questions because they were not having full information about the presentation, because too many questions were there. After the presentation, I answered most of their possible questions in the presentation. For that reason, there are no queries. But still.
Yeah, so.
Hello. So,
Yes, please.
yes, kind permission from the honorable organizer, ma'am. This is Mustafa Shaman Firdaus. My heartiest gratitude to the honorable resource person, ma'am. Ma'am, may I please ask my query?
Sir, your voice is not clear.
Okay, ma'am, may I please ask my query?
Yeah, you're most welcome.
Thank you very much. Ma'am, actually, the fact is that my first question will be in the homogeneity. Would you please be kind to go to that portion once again, please? I mean, heterogeneity and homogeneity, which thing is actually, required?
See, sir, I'll put it in simple terms rather than complicated terms. When I say homogeneity in variance, the variance should be equal. It should be one and the same. Okay, that is what. Heterogeneity, all those things, let us not get into the picture of it. Homogeneity means the variance should be one and the same. Just check with the Levin's test. In general, you can check it with the this one, Levin's test. Or if not, as I said, you can check the variance between the larger one and smaller one. I showed a sample, isn't it? The larger variance divided by smaller variance. If it is around 4, that is sufficient for us.
So the variance should be equal.
Equal.
That is, okay.
Homogeneity. Homogeneity.
Okay. So homogeneity is expected.
Yes, it is expected. And please remember, if there is a difference in the variance also, there is one more t-test in the 2-sample t-test, where the variance is not one and the same. That test also you can apply.
Ma'am, this is not clear to me. Would you please be kind to elaborate this thing, please?
See, actually there are 2-sample tests. Under 2-sample test, there are 2 tests. One is where the variance is one and the same. If the variance is not one and the same, there is one more test which we can apply. For that, there is a simple correction with regard to the standard deviation of the sample. Little change in the formula, and accordingly you can proceed. That's not an issue. If it is not same also.
Okay, ma'am. Thank you very much. So, ma'am, for parametric, tools, would you please be kind to suggest some reference material, some books or some?
Yes. I'll be sharing the material. As I said, book related. You can go through it. It is self-explanatory. You can just explore. It also explains using SPSS how you can do.
Okay, so what is the name of the book, ma'am, please?
I'll just share it with the coordinators. You can check it out.
Okay, thank you very much, ma'am. And with kind permission from you, maybe may I be in your task through email for further learning, please?
Sure, it is written in my PPT. The PPT will be shared with you. You can make a note.
Thank you very much, ma'am. Thank you very much. And once
You're
again, my
most
hearty
welcome.
gratitude to you for your such excellent lecture for us. Thank you very much.
Yes, ma'am. Good morning, ma'am. Good
I
morning,
think,
Dr. Anurag. Hello.
dear participants, please.
Yes, ma'am. This is Dr. Anurag Pandey, ma'am.
Yeah.
Yes, ma'am. My question is this: that I got one question. I'm just little bit confused about it. The
Yeah,
question
please.
is this: whether male and female are equally represented in the sample. So, can it find out through the variance test, or we should find it out through the percentage?
See, that you can do it. First and the foremost thing, what you're supposed to do is, whenever you're drawing a sample, there are certain basic conditions for it. If you want to see that it is a representative or not, go for that stratified where the proportion is one and the same while drawing the sample. If you are doing certain simple measures, if you take, automatically all these assumptions will be met, especially while drawing a sample. But the thing is, we don't, while drawing the sample, we have lot of limitations. Like if I want to administer any questionnaire to an individual, he may not be ready to respond, because of which all these problems we come across. That's how it is.
So
Right.
I should go for the question is only whether the male and female are equally represented in the sample. This is the question. So I should go with the percentage to find out that this is 52% or 48%, such kind of percentage we should consider as an equal distribution, or we should go with the test.
There we are not talking about distribution. Please make it very clear. There we are not talking about the distribution. We are talking about sample is representing the population or not. For that, you use a sampling technique which follows the representation or not. Go for proportional stratified sampling method, then it will be fine.
So simple, we have to find out the percentage.
Yeah, that is one way. That
percentage.
is normal way of doing it.
Okay.
Good morning, ma'am. My question is that for autocorrelation, you have said that we can go for the Durbin-Watson test. But if if this assumption is violated, if we are not meeting the criteria of Durbin-Watson, then which non-parametric test we can go with, ma'am?
Actually, coming to this autocorrelation, that falls under this one, regression and other things that I don't think so we have covered in today's session. Again, what we are going to do is in regression, whenever there is whenever there is independence is there, you go for transformation of data, that linear regression, go for a transformation of the data. There mostly we go for this one, log of the data or power of the data, something like that we can go and then check whether there is a normality or not. And then you can do. Generally, it happens in, econometrics, financial data, it happens generally, autocorrelation.
Okay.
Because we tend to measure one single variable on various time measures like daily, weekly, monthly, you do it. Because of that, you get into that problem.
Ma'am, my one question, respected ma'am, very good morning, ma'am.
Yes, please.
Ma'am, this is Ravindra Kumar, PhD scholar, Department of Management Sciences, Mahatma Gandhi Center. Ma'am, I am pursuing my PhD under title and a study of international trade. I study of empirical study of international trade of India with select BRICS nations. Ma'am, I have taken the two variable export and import for measuring the economic growth between India, Russia, and India, China trade. What's the type of parametric and non-parametric test we have to take, ma'am?
See, one second. First and the foremost, this falls under econometric. This doesn't fall under this parametric and non-parametric test. Generally, what happens is this parametric or non-parametric test, these are the applied on, what do you say, primary data. The exports and imports, that is secondary data. And not only secondary data, as I said, over a period of time, you are measuring this exports and imports. That is entirely, totally a different concept where you can go for it. Right, it falls under econometrics, not here, this side of it. Maybe that we can discuss in later on, maybe personally we can discuss that. So rather on this platform.
Ma'am, about the table values. How do we find the table values?
There is a disturbance. Please, the people who are not asking any question, mute yourself so that we can focus on the person who is asking a question. Yes, I think.
Can you be a little bit loud?
Participants, please request you to mute yourselves. The questions are not being heard, and the resource person is trying to answer all the questions. Please.
I think somebody asked about how to find out the table values. As I said,
Yes.
the table values are dependent on only two factors. The first one, two aspects. That is, the first one is degrees of freedom. The other one is level of significance. If you refer to the any statistical book, statistics book backside of it, you will get. For t-test also, you will get a table value. And also for ANOVA also, you will get. But whereas when it comes to ANOVA, you will be having 2 degrees of freedom. That is, one is for the numerator, the other one is for the denominator. Again, 5% level of significance or 1% level of significance. For only these two, generally it is available. To overcome all these, what do you say, all these limitations and these problems, the software is helping us to draw our conclusions based on the p-value. For whenever you are using a p-value, you need not check for the table value or anything. Just check the table value. Is it less than the level of significance or not? Or is it greater than level of significance or not? If it is less than, what you will say? There is a significant difference. If it is greater than, you say that there is no significant difference. Simple rule, rather than getting into all such problems of how to get a table value, where to get it, all this, because most of the softwares will give you the p-value without any problem. Right. Next query, please.
I think Mr. Shankar has posed 1 or 2 questions.
Yes, ma'am.
Yeah, is he still there? You want to ask? I will just read over, ma'am.
Yes, ma'am, please.
Yeah. Just trying to. Can we use skewness and kurtosis value to define normal distribution of data, ma'am? That is a question.
Yeah, you can use skewness and kurtosis, but when you draw this normal curve using a normal curve, that will take care of it. When you draw the normal curve, or when you use this either of this test, Kolmogorov-Simron test or Shapiro-Wilk test, that will take care of it. You need not worry about skewness and kurtosis. But if you want, without using any of this test, by just observing the skewness and kurtosis also, you can do it, because it will tell you whether it is symmetric or not. So based on that also, you can proceed. But whether the mean and the standard, whether the mean, median, mode is intersecting all those things, it will not be giving a clear picture for that.
Thank you so much, ma'am. I think all the participants' questions are completed. Yeah, so I would like
Madam.
to. Yes, anybody else?
Yes, Madam. I am Dr. Karnailal Bhattacharjee.
Okay.
Madam, first of all, thank you for your lucid and nice presentation.
Most welcome, sir.
I'm just want to know about the term actually level of confidence. Please briefly explain.
Okay, level of confidence. In general, we say that level of significance, we use this word. See, whenever you're trying to answer any query or anything in general, you cannot say that you're 100% correct, 100% true. is it not? Especially when we know that there are a lot of uncertainties in this world. So what you're going to do is, when I say the level of significance is 1%, okay, it means that whatever you're stating is right to an extent of 99%. Or in other words, if you're taking 100 cases, whatever you're stating will be true in 99% of the cases. It can be false only in 1% case. In other words, if I take 5% level of significance.
Okay.
So what will happen? You're true to an extent of 95% cases. You might be wrong in the 5% of the cases. That's the reason I use the word level of confidence rather than level of significance. Right? Thank you.
Thank you, madam.
Thank you, sir.
Any more questions, dear participants?
Ma'am, feedback form sent कीजिए ma'am, please ma'am.
Yeah. It'll be sent.
Ravindra Kumar ji will send the feedback form. See, questions are very important. No, just a couple of minutes, please.
Yeah, you'll receive, dear participants, you'll receive the feedback form. The resource person has taken, interest in answering all the questions. Anyway, yeah, let me propose now.
Kumar Naval.
Yeah.
Please
Yes?
Harshita, you want to ask a question?
No, ma'am.
Dr. Vijay, can I request you to on the video, please? Okay. Proposing the vote of thanks.
Yeah. Yeah, so I take this opportunity to propose a formal vote of thanks. At the outset, Madam Saida Tabassum ma'am, your presentation was so excellent, so vivid, so clear, and I think has enriched so many of our participants. I thank you so much on behalf of the department, and I thank also our principal, Dr. Achita ma'am, our director, Dr. Renuka ma'am, our secretary, Sir Sudarshan Reddy sir, and our HMVS secretary, Dr. Professor Mutyam Reddy sir also, who have been the support behind the conduct of this 10-day FDP. And I also thank the participants who have shown so much interest in not just attending, but actually participating in this session. Thanks a lot once again. Thank you, ma'am, Dr. Saida ma'am. Thank you so much.
Thank you, ma'am. Before concluding, just a few words. I would like to thank Renuka Sagar ma'am for giving me this opportunity. And also, I would like to thank Reddy College for conducting such programs. As usual, as always, you conduct lots of programs to enrich the knowledge of the researchers, research scholars, and also people like me. I have been attending your programs. Thanks a lot. I would like to thank the management of Reddy College for giving me this opportunity and conducting such programs. Thanks a lot.
Thank you, Dr. Tabassum. Thank you so much for being the part of this program. We will look forward for you to be there for all the programs in the future.
Sure, ma'am. Sure. Most welcome.
And your participants, we look forward for tomorrow once again, your participation.
And sorry for extending the time. Very sorry.
No, it happens usually whenever we have such kind of online meetings, usually it will happen. And but the session was very excellently done, very excellently done, Tabassum.
Thank you, ma'am. Thanks.
All the audience.
The extra time we spent was excellent. We gained a lot of knowledge, so we wouldn't mind spending more time with your session. Thank you, ma'am.
Thanks a lot. Thanks. Shall I leave the session,
yes,
ma'am?
Thank you, Dr. Tabassum. Thank you so much. You can leave. Thank you.
Thank you, ma'am. Thanks.
చార్ట్ పెడతారు మేడం వాళ్ళు ఎవరిది అది
Dear participants, kindly mute your microphones.
మేడం అది ఫామ్ మేడం
Form పెట్టారు. We have put the form. We have put the link in the chat box. Yeah.
Ma'am, you will also be sharing the PPTs and the documents. What the?
Yeah, we will ask the resource person to share. In case she is willing, we will forward the same to you in the WhatsApp groups. All the WhatsApp groups we have created so far, we'll put them in the WhatsApp groups.
Yes,
it's
ma'am.
a promise from us.
Yeah, she had promised that she will share it with.
I have Dr. Tabassum's PPTs. Immediately, I'll share it to you in a couple of minutes.
Thank you.
Thank you.
Ma'am, thank you. Shall we exit?
Dr. Vijaya, keep announcing to the audience that the link has been posted for the feedback. Maybe for another 10 minutes or so.
Okay, sure.
Continuously, and you ask them if they have completed the formality. Then you just can ask Dr. Lalita to wind up the session.
Excuse me, ma'am.
Yes, please.
Yesterday's feedback link, ma'am.
Have you filled, sir, today's feedback link? It's done?
Yes, ma'am.
Okay, thank you. So regarding yesterday's problem,
Excuse me, ma'am.
Yes.
Ma'am, yesterday I had a lot of network glitch, so I could not fill up the form. And first day I could not join because I got the information about the feedback late. So day before yesterday itself I joined. Will it be okay, ma'am?
Ma'am, I think what you can do is you please enter today's feedback form, and
I have done it, but yesterday
we will look into that later, because I think there's few more days anyway, isn't it? So once I think you're regular on those things.
Today's feedback I have already done it.
Sure, ma'am. Don't worry. We will be considering all that. Right. Okay. Because we have still so many more days of technical sessions. So the participation throughout will be considered.
Okay. Okay, ma'am. Thank you. Thank you so much.
Good afternoon, ma'am.
Yes, please.
Ma'am, ma'am, the PPTs would be shared in the advanced.
I think in the WhatsApp group they will be sharing, ma'am, the PPTs and any other related matters.
Group. I saw a link in the chat box today. Is that the link that we need to join, or the advanced research group?
It's an advanced research group, ma'am.
Anything would be the same, ma'am.
Yes.
Okay. Thank you so much.
Good afternoon.
Ma'am, tomorrow's program, who is going to come?
Yes, ma'am. Yes, sir. You are asking tomorrow's?
Ma'am, regarding tomorrow's session, who is the resource person and what are the...
Just give me a second, sir.
Also, it will be great if you could share us the entire workshop details, as in every day's program schedule, if it is possible.
Yeah, sure, ma'am. We'll look into it. And tomorrow's, as you were asking, the speaker is Dr. Kandela Ramesh. He's a speaker. He's from Geetham University. And he'll be speaking on, again, a research topic related to analytics. So that is for tomorrow. And as you said, ma'am, we'll look into about sharing the others. So I'm discussing with Rinka ma'am and that's right.
Good afternoon.
I hope.
Thank you, ma'am.
Yes, please.
Ma'am, I am filling this feedback form, and there is one last section in which we have, this is untitled question, and there is option 1. So, ma'am, what we have to mark this section or not, ma'am? Like the form is same, but today this section is added.
That is by mistake.
Yeah.
Okay.
Yeah.
So, ma'am, they need to choose it, or we should.
You can decide, ma'am, no problem, even otherwise. Yeah, it's not mandatory.
You can ignore that question.
Yes, it's not mandatory. Right.
Good afternoon, ma'am.
Yes, sir.
Ma'am, sessions were very wonderful going. Is this all available on YouTube as recorded?
I think yes, the recording can be shared with you all. Yes, Lalita?
Ma'am, they're all available on YouTube. They can type the session, the seminar title, and they can fetch them.
So Dr.
Thank you
Lalita
very
has
much, ma'am.
answered your question. Yeah, you can please type the title and check for that. So I hope all the participants have filled the feedback forms. Somebody's asking, I think, link of the channel. What ma'am was just, no, Dr. Lalita was mentioning is, yeah, that's also shared here. Mr. Ravichandran, the feedback link is already posted. I think you'll have to scroll up a little to check.
If all the participants have filled your feedback form, we shall end the session.
Thank you very much, ma'am. Thank you very much.
Dear participants, we are ending the meeting. See you all tomorrow sharp at 9:45 a.m. like today. See you all tomorrow.
Okay, ma'am. Thank you very much, ma'am.